All right, so now as far as trying to remove some of the more boring words from here and make sure that this is actually interesting. So, oh, look at that. And of course, now this guy's going to choose not to work. Is that right? All right. Worked. That's great. So again, grabs the amount of memory. We do some cleaning. We get a list. Boom. Round about here is where we're going to want to start thinking about, do we really need to have to and words like that? So what we're going to do is actually, if it's okay, I'm going to kind of strip away some of the code so I can get rid of that particular error and start adding some code. All right. So so the whole point for the first bit is I'm just going to enhance the list. And one of the ways to do this in a list fashion is once I've finished doing my cleaning and I've converted it to a list, I can always go list Morris poem dot remove. It's one of the list methods. Right here, you can see back in the list methods, remove. I can remove. So let's go ahead and remove 2. All right, and let's go ahead and run that and see what that does. And we go next, do the cleaning, and there's a split, and now we're going to basically target this element. Now watch what happens up here to 2 when I remove it. Boom, it gets taken out. We're now probably down to 216, and everyone gets kind of shuffled up. Pretty neat. Now, similar to the replace, if I got some other words I want to get out of there, I could just go remove, dot remove, and then remove another one, like and. That would be another cool way to do it. So I go, go. Here's my list. So 2 is going to leave, and's going to leave. So look at elements number 1 and elements number 4. As soon as I go next, boom, they're out. And I can't remember, one of those might have had more than 1 value in it. Maybe not. Okay, well, let's see one more. I think it is in there at least a few times. So let's get rid of it as well. Remove it. I want to make sure that you guys see that this thing will remove all occurrences of this. So we have the 2, we have the and now as we fly over, I don't know how many, but I saw definitely at the end we had 2 its, and 206 and 211. And we have 2 is's, which I can't remember if that's actually what I coded for or not. Did I code for that? No, just it. Okay, well, whatever. Let's go next. And non-type object to remove. Well, I'm not entirely sure why that blew up. So again, common debug method, take out what you did first, and then see whether or not everything's back to normal. Nope, everything is not back to normal, which means something happened that had nothing to do with that. All right, next step. It's all panic. Coding is all panicking, by the way, because, you know, but you got to panic in a cool, collective way. All right, so I'm making that into 2 statements. Close that out. Go next. Okay, so now let's do this guy with the remove it. 2 dots, but 1. Next. Remove 2, remove and then at the very end, we should lose the its. I actually didn't do it. Did you only remove 1? Wow. There you go. Okay, so maybe it only removed the first one. I you know, thinking about it now, always going to here and have a look, but I wonder if it there might be other parameters you can pass in to get it to remove all of them. I don't want to spend too much time trying to fix this problem because this is not the way I would do it anyway, right? For one thing, by the way, it might be better to convert it to a set than convert it back to a list and then start doing your removing and then convert it back to a set again. That might be another way to do it. But, you know, we've already got the sets in there. So let's now go to way 2, which is going to be way cooler anyway. I'm going to get rid of, I wanted to demo the removing to show you guys that you guys can remove elements in a list. But we can go one step further now and actually do this in the set. All right. So when I talk about sets, they come with slightly different methods. And there isn't really a remove, but there is a difference. So here, let me just kind of show that in a smaller, example. So I'm going to have this guy being a set. So it's going to be a set, and I'm going to use the curly braces here and here. And this is a common thing to do, by the way, when you're thinking about code. So I'm going to go this set. I'm going to go yuck set, and my yuck set is just going to be apple. All right. And let's get rid of that. So we're just run them. Oh, apple's got to be in quotes, so otherwise it becomes a variable which nobody knows. So let's do that. Go next. So I got myself 2 sets. Now, what I could do is use some of these methods. One method for sure would be union, which actually contains the combination of the 2 sets. And I wonder actually. There's a great example right there of sets, right? So if we basically had a tomato set with these attributes and this attribute, and we had apples of these attributes, the union is the whole thing. Okay, the union is the whole thing. So back over to here, what I could do, let's make actually something different. Let's put an orange in there, orange. So I could take this set and union it with yuck set. Now I think actually this won't work on its own, will it? Yeah, it's going to say, hey, oh, by the way, yucket's not the right word, yuck set. Let's try that again. Visualize and go to the end. I still think you're probably not going to work. This is great. Yeah, because I didn't say to do anything with it. I just basically said, hey, union it. It would have been nice had I basically had an assignment on it. So let's go. This set is assigned the combination of this set and yuck set. So if I go and I go next, there's yuck set. Now watch this. Once we get past the union, boom. The old set's gone, and now the new set, which combines the 2, are together. So that's kind of cool. And actually, I did appreciate how the arrows moved around. It really did let go of the first set into memory and created a whole new thing. All right, good deal. Now, the reason I called it yuck set is because, funny, I said orange, but I ended up putting Oracle in there. I wonder what that means. Anyway, if I go apple, I'm going to union those 2 together. So I go visualize, and I go next. So there's this set. The yuck set is apple. And then if I union them together, it's going to be the same. Because remember, duplicates don't exist. It's a set, so duplicates don't exist. The 2 cherries become 1 cherry. The 2 apples become 1 apple. It doesn't exist, right? There's no duplicates. It's a set. Set are always unique. Now, the reason I call them yuck sets is what happens if you want to get rid of apple from this set? Well, there is another operator out there. That operator, that's lists, no, that's sets. Remove would remove a specific element. So if I knew I wanted to remove apple, I would use remove. But there's also something called difference. And what difference would be this set. So red, savory, fruit, smooth skin. This set minus this set leaves you just with these. Okay, so over here, if I go this set, I said minus because that's the way it typically is, but difference is the way it is in Python. But this set minus the yuck set. Watch what happens now. So we get, there's that set, we get the apple, this set then gets destroyed, and a new set gets created with just banana and cherry. So that's how you can get the difference. Now, how does that work in our world? Back over to here, I had that example where I was getting rid of to and, right? So after I got a set, I could have a set. Okay, and I guess I should say this now. There is a concept behind getting rid of small nonsensical words, and that concept is called stop words. That's the name of it. So stop words is a bunch of words that you basically want to get pulled out, like on, the, that kind of thing. So I'm going to call this thing stop words. What is it? It's a set. Actually, I guess I can just go straight in here. It's a set of and, to, and we'll say. Okay, so there's that. So let's run this guy. So we go through, do the punctuation cleaning, we create our list, we create our set. Now I've got myself another set, to, and. And I don't see them in here. All right, so there's at least I'm sure someone here, there's to, and would be in here somewhere. So anyway, what I could do now is to get this set out of this set, I would say set Horace poem is assigned set Horace poem difference and pass in the set stop. Actually, it's stop words, by the way, stop words. So I go, and boom, 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 boom. There's my list, there's my set. And now this set will change, and we're probably the only thing our eyes are going to see is we're going to see it shrink by about 3 entries. Or it's just going to blow up because I forgot a thing here. But this is the whole copy paste thing. So it's not Horace, not Saint Horace, but set Horace. Let's go again. Close. Good. And now I'm hoping I'll see this thing shrink by 3. And it does. It shrunk by 3. All right, so that's another way we could get rid of the stop words. And it's not too hard to imagine that maybe you could have a list of stop words kind of hard-coded in here, and then later, if you want, you can say, are there any other words you'd like excluded? Right, and go into a loop there, build a nice list of the words you want excluded, I should say, convert that to a set, union the sets together, and then get that set taken out of your list. You could do that. All right, but even that isn't necessarily the best way to do this. So the best way to do this, I'm going to go and bring up Python Anywhere, because here's the thing. I got I'm showing you some manual clunky ways, but Python's been around a while, and people much smarter than me have come up with much better ways to do this. The problem is that this environment of Python, the visualizer, can't really handle it, because it's really just meant to demonstrate some small ideas. And all I'm doing when I constantly am using this is I'm trying to show you how this thing is thinking in memory. That's all I'm doing. Otherwise, we could just use idle, or we could use Python Anywhere, or you could use one of the other IDEs. So give me a second here. I'm going to kind of just pause the video, and then we're going to come back and show you kind of what I got ready. Okay, so I've moved on to Python Anywhere. I created a program called stopwords.py. This one I might actually stick out in the content section. I got some quick documentation. So here's a link, by the way, to the actual poem. Here's a link to the actual text. And what I'm about to do is talk about stop words done properly. All right. Right now, there's no stop word technology in this at all. So if I was just to run it, I should save it and then run it. We'll see down here that apparently his is used 23 times in this poem, right? So that's what that is. And you can, get a sense as to, like, for example, if I go set Horace poem, there's the set. And this is my little loop, right? Where I basically say, what's the max count? Set to 0 for word is in there. How many becomes the count of the word. If I've got more than the max count, set the most used to that. And actually, and then set the max count to be how many it is. And so at some point we got his. I can't run this through you step by step anymore, but I think you can always go back and just watch this run. Because this next bit, you don't have to care too much about the step by step thing. Right, so up here, this is my sort of quick, brutal way to get rid of words that you know that you want to get rid of. Here is, and then I kind of reset it, change it to a set. I create myself a nice little set of stop words and then do the difference. That's what I did a few minutes ago. So now this is one of the proper ways from this list of getting rid of stop words. And it is kind of cool, and it demonstrates a very interesting idea. So what this does is this basically goes and grabs, it grabs a program, I should say, from a module, and the module is called GenSim. I don't know too much about this, to be honest, because I was using another one, but anyways, GenSim. And so what GenSim does, GenSim is a bunch of programs that really intelligent people made. And in there, there's parsing, and inside of parsing, there's something called pre-processing. And in there's a program called remove stop words. And to use it, all I got to do is I basically got to use that function, remove stop words, pass in this case, I'm actually passing in the entire string, right? So this is actually going way back to this string. It's not using a list, it's not using a set. I'm going back to the initial text here, and I'm ripping out the stop words. So this I would have loved to have shown in the memory of the visualizer, but the visualizer won't let you do fancy imports like that. So, and that's okay. So, maybe what I could do though to sort of show this off is I'm going to bring this guy back in. So the poem, I'm going to create a new variable here. Actually, I'm going to go clean. Okay, so I'm going to create something called clean, and then from the clean, I'm going to go print the clean. So print str Horace clean, because by now the punctuation's taken out, it's all in lowercase, and now all the stop words are gone, right? So that's kind of what's going on there. It's clean. Let's. I don't think there's a quick way for me to comment this out. Is there? It doesn't matter. We'll end up seeing the poem first, and then the clean poem, and then we'll see the rest of the output. So let's just go run. And it says it's not defined. That's unfortunate. Why would it matter if it's not defined? Because it's not Horace clean, it's the poem clean. Nice part of the IDE here telling me that there's an issue there. Thank you. I should have paid attention. Let's run again. All right. So what happens now is that does look like a lot of the useless words are taken out. Like when you know what the poem actually is, the poem starts with much to his mom and dad's dismay. And what's left here is mom, dad, dismay. Horace ate himself one day. Horace ate day. He didn't stop to say his grace. Stop, grace, sat, and then ate face. I'm sorry for bringing my teenage years into this, but I am finding great humor in this. Anyway, all right. So, but it did actually, it went through and stripped off and left us really mostly interesting words. And if there were other words here that we decided we didn't care about, we could, in theory, go through. Oh, how come I got won't, by the way? Oh, won't wasn't one of the ones that I did here. Won't wasn't one of the ones that I did. Well, let's get that done. Won't is going to be changed to would not. All right, let's run that again, by the way, just for giggles. There's an error in saving. Well, I'm going to save you there, and I'm going to run it again. All right, good deal. Anyway, cool. So that right there kind of showed a really neat way to remove the things. Then what I would do at this point is I would then start to make myself a set from that. So I'm going to go here. I'm going to go into my set, copy, set. So set horse poem is going to be the set of the clean version. And then that's useless. I don't need that anymore. So that's my, oh, wait. So this is just a bunch of text. So the next thing I got to do is do the clean part. So I got to go list horse poem clean is assigned the string of horse poem clean dot split. So that'll give me a nice table to pull from. Then the set is going to be based on the list. All right. And then I'm going to go through here, and I'm going to go from the word is going to go from the set. But, you know, by the way, make it clean. So clean, words going in clean. We're going to find out how many times it's in this particular table or list. Clean, and then the rest of this should work just great. All right, so let's just run it. Let's save it, and then let's run it. All right, so apparently 8 was used 4 times. That's apparently what we're learning from that. So we could try to verify that right now. So let's verify that by going into here and do a nice little print. In fact, actually, as we're going through the loop, I'm going to say print word and then the int how many, and we'll actually see it come out here. So let's go run. So there's 8 with 4. Yeah, I guess I gotta trust the data. So 8 is in fact there. Now why it's there twice? Oh, it's there twice because I got the second print statement. Yeah, so that's it. Tell you what, just to make that a little bit cooler. Yeah, here's where a nice sorted order would have been good, and I could have done something to that effect too, but I have to admit I'm a little bothered, a little bit. Oh, I get it. So what it did, like I'm wondering why 8's obviously appearing twice, is what I'm wondering. But I don't see the second print statement that would have printed the second 8. So let me just run it one more time to see whether I'm getting some background noise here. Nope, I'm definitely getting 8 twice. All right, that's awesome. So I tell you what, let me just do a quick print of the set. So print, actually don't have to go print, I just go set horse poem clean. And it doesn't exist. Oh boy, you know, could this there it is, good deal. Okay, so eyeballing it's the worst way, but I'm just kind of looking to see that I don't seem to see 8 there twice. In fact, I don't even see it once. So that's interesting. I just see it right there. There's 8. And interesting enough, too, it does appear like as the 4th one. So there's 8 oh mother thighs, 8 oh mother thighs, and then foolish. So I'm still wondering, why is that at the bottom? It's almost as if there's a print statement there that I can't see, which is driving me crazy. Because that's how I would have wanted it to print. I would have wanted like the winner is, and then basically print that line. So let me do that. Print winner is, comma, the most used word, comma, the max count. I will show you what's going on. See? Do you guys see why I'm so confused at this point? It's like there's another line right underneath here that's printing that. All right, well, you know what? That's enough of that. I got what I wanted out of it, which is basically to show you ways to remove words. All right, I'm obviously going to ask you to try something like this yourself, and you you can choose to do it exactly the way I did it, or you can choose some other way if you want to try and remove stop words. But I'm going to more or less ask you to basically take in a string of characters and then do some analysis on it. Now, a couple things. Some of you might be going, oh, there are definitely some limitations here. Also, some of you will be thinking that perhaps I've abandoned my input-output processing thing. Not totally true. Very soon, we'll be learning how to read stuff from files. When we learn how to read stuff from files, this will likely end up becoming an input statement, right? Then, obviously, this ends up being the processing statement or processing put there. And then there's my final output there too, right? That's kind of how that would go. And then this gets to be a lot of code. We are going to start to learn how to break them up so that we can create our own functions. So instead of having a bunch of this crap just sitting in our processing section, we will have something that basically says, Horace program is assigned, clean up the poem, and then we'll feed in this. And this line becomes a lot easier. This becomes something more like we can either have that just on it by itself in the processing, or have that in another section, which basically says make the sets and tables. And probably what I'd do is I'd probably put this whole set into that, right? Where I basically go in there and remove the stop words or whatever. You know what I mean? Anyway, so you can break up some of this processing to make it a little bit easier to read. This one would probably be one function out there, which I'd basically say, give me the most used words and how much the count was. So that's one thing we'll do to make this thing a little bit cooler in the future. And the other thing we're going to do is, I haven't talked about it yet, but there's a whole nother data type out there. And that's called the dictionary. And I think we're almost at the point that we could maybe bring a dictionary into this program as well. So I'm going to sleep on it before I decide what we're going to do with that. But a dictionary is probably one of the coolest data structures out there from that particular chapter. And so we've done the list. I hope you're feeling pretty comfortable with the list. I hope you're feeling fairly underwhelmed about the tuple, because all it is a list that you can't change. I hope that you're feeling okay with sets. Sets, again, they're just like the Venn diagram that I showed you before, this guy here. It's just a programmatical way to basically take two or more data sets and combine or play with them, right? And this was a great use of that, by the way, finding the unique words in that particular poem. They're all pretty exotic, and then the dictionary is the most exotic, and it's really cool, and you don't really get too far in Python without it. All right, so that'll be the next one. And thinking about it now, what I'll probably end up doing is introducing a dictionary to our new stop words program. So enough of that. Sleep on it. We'll talk later.